Hello and welcome once again. So in today's video series we're going to tackling 2012, and in this first part of the video we have a question, which is question 1 and 2 and 3 to come on, you see, and the second part is question 5. Okay, so in this first part of this video, the first question reads: given that the root of the equation x squared minus bx plus c equals to 0 are alpha and beta, form the quadratic equation whose roots are alpha plus 1 on beta and beta plus 1 on alpha. And the Roman 2 say find the values of the constant k for which the roots of the equation x squared minus 2 into 1 plus 3k all that multiplied by ax plus 7 into 2k plus 3 equals to 0 are equal. Okay, so for the first part, it's almost similar to what we have done so far. The only difference here is the roots which are given to us. Instead of p and q in the first video, we are going to have alpha and beta, and which is the most common root you're going to ever see in mathematics, especially quadratic equations. So our equation is, so you have question 1, Roman 1. Our equation is x squared minus bx plus c equal to 0. Okay, so alpha plus beta, which is our sum of roots, equals to negative b on a, right? Negative b on a is going to be equals to is going to be equals to negative, then negative is going to be plus b on 1, and again alpha beta is going to be a c on a, and our c, whatever c is c, so we have c on 1, which is c as well. Okay, so these are the roots of the question. Now heading to the sum of new roots, and our roots here are alpha plus 1 on beta plus beta plus 1 on alpha. Okay, so for the sum of new roots, these two new roots, we're going to sum them, and it will give us alpha plus beta plus 1 on alpha plus 1 on beta, and these two can be simplified because we can easily have any root from these two. So this will be equal to alpha plus beta plus alpha plus beta divided by alpha beta, after simplification, of course. Now we already have the values alpha plus beta and alpha times beta, so just about substituting everything here. So sum of new roots is equal to b plus b on c. Now you can choose to leave your answer in this level, at this level, but I choose to simplify it again. Okay, so equal to c, do the LCM. Okay, so c divided by 1 is c times b, we have bc, plus c divided by c is 1 times b, we have b. So simplifying the numerator, we're going to have b into c plus 1 divided by c. This is for the sum of new roots. Now for the product of new roots is going to be equal to alpha plus 1 on beta times beta plus 1 on alpha. Okay, now this one is multiplication, is not division, so we need to open these brackets, multiply this by this and this, and then this and this and this, going gradually. So we have alpha beta plus, here we're going to be 1, here again is going to be 1, because alpha times 1 over alpha is 1, the alpha will cancel out. So we have 2 plus 1 on alpha times 1 on beta. At the end of the day, we'll have 1 on alpha beta. Okay, yeah, thank you. So equal to, what is alpha beta? This is c plus 2 plus 1c. And again, like the last time, we're going to carry an LCM. So it's going to be equals to all this divided by c squared plus 2c plus 1. And this is exactly c plus 1 all that squared roots. So it's going to be equals to c plus 1 all squared divided by c. This is our sum of new root. This is our product of new root. Now let's get our new equation. Now formula for the new equation is x squared minus sum of new roots, all this multiplied by x plus product of new roots equal to 0. So this implies that we're going to have x squared minus this value which we get up here, b c plus 1 divided by c plus 1 all squared divided by c is equal to 0. So this implies that at the end of the day we're going to have, multiplied by x here. I almost forgot that. We're going to have x c squared. However you want to put it, remember multiplication is commutative. So you can see be c x squared. Oh, sorry, not c squared here. X squared c. But no matter the order you put it, you see the same thing. Okay, minus b into c plus 1 or x plus c plus 1 squared equal to 0. So this is our quadratic equation.